Hey everyone, it's Tony from Archism. Today we're going to be going over projectile motion problems. So this is actually going to be a special form of the one-dimensional kinematics problems that we did a couple examples on, the K problems, K problem 1, K problem 2, and so on. If you guys haven't watched those, you don't really need to understand those to get here, but you just need to have a little bit of mastery of the kinematics equations in order to start doing projectile motion. So in this video, I'm just going to be overviewing really how projectile motion problems work, and later on I'm going to be going over actually how to solve them. So the differences from one-dimensional cake problems. Well, first off, the first difference is going to be, well, yes, they're in 2 dimensions. So you have to watch out for that. That just means that you're going to have a velocity in the x direction and in the y direction, which is going to be noticeably different from doing the one-dimensional version. In the one-dimensional version, they may ask you to just calculate an object that's going in a straight line. Usually, in this type of kinematics problems, you're going to be doing something that's moving in two dimensions, like in an arc. So what you're mostly going to be using when doing projectile motion problems are going to be your second cake equations. If you guys don't remember, it's going to be delta x is equal to v initial in the x direction, delta t, plus 1/2 ax delta t squared. When doing projectile motion problems, it's especially important for you to remember your variables because you're going to be moving in 2 directions rather than just one. So you see right here I use delta x, and delta x. So this just means the initial velocity in the x direction and the acceleration in the x direction and the displacement in the x direction. But in cake 2, we're going to add the exact same thing, but except it's going to be in the y direction. So delta y is equal to VIY delta t plus 1/2 AY delta t squared. The third thing that you really want to remember from the differences is that you're going to want to always draw a graph or an axis to decide how you're going to solve the problem. So what my physics teacher taught me to do is actually in the corner of your problem, you just want to draw like a little axis, delta x, x on the x-axis and y on the y-axis. This is important because you have to remember which direction the particle is accelerating in, and also how you're going to be applying your equations. So right here I said like parametric equation graphs. If you haven't done parametric equations, what that basically is you're going to have some sort of graph right here. Like for projectile motion problems, most of them are going to be parabolas, so it's going to look like this, right? So, and you're on the x-axis, you're going to have distance in the x direction and position in the y direction. So it's going to be kind of like a graph. You have right here. Let's say you've gone 1 meter in the x direction and you're 1 meter also in the y direction. And then right here, you're going to actually also put the time. So let's say you get to 1 meter, 1 meter high and 1 meter in the horizontal direction, and that's going to be over the over 1 second. So you're going to want to remember that at a particular time, you're going to have a certain distance gone in the y direction and a certain distance gone in the x direction. So you're going to remember that you're going to be tracking time. So it's very important that you actually draw a graph of your situation so that you remember what you're doing and you don't remember and get confused. This really helped me when I was doing these problems. So please don't forget your axis and your graph of the situation. So then moving on to our next one. So actually going into solving the problems. So your first step, as I said in the last slide, you're always going to want to draw a graph and have an axis labeled. So just simple like this, and then your axis, x and y. And what you really want to remember when you're doing these problems is that velocity is going to be a vector. You're not going to be you're not going to have just velocity just moving forward or something like that. You're going to have velocity like this or like this. And because you have that, you're going to have a velocity like this as well as a velocity like this. So if you're doing the cake equations, you're going to want to do it for both directions to make sure that you're getting the full picture. One thing to remember is that the velocity in the x direction is always going to be constant. The reason that is because there's no acceleration in the x direction when you're doing projectile motion problems. So when they ask you, let's say you have a problem and I'm standing on the top of a cliff and I throw a rock down, and they ask you what's the velocity in the x direction right here. You just have to remember what your initial velocity was right here. Because there's no acceleration, the x velocity is always going to be the same throughout these problems. However, in the y direction, you're going to see that the velocity in the y direction is going to be affected by gravity. And this is going to be negative. Rather than in your usual cake equations, you remember that, oh, well, acceleration in the acceleration, if they're getting faster, then it's going to be positive, or acceleration if it's getting slower, then it's going to be negative. But acceleration in the y direction in projectile motion problems is always going to be negative. The reason this is because on your graph, if you remember from your graph, you're going to be accelerating downwards. And that's going to be equal to negative 9.8 meters per second. And that's because of gravity. So it's accelerating towards the negative y direction. If it was accelerating upwards, but gravity is not upwards, as you all know, it's always going to be pointing towards the negative y direction. So it's always going to be negative. That's something that you need to remember. You absolutely cannot forget that acceleration in the y direction is always going to be negative 9.8 meters per second if you're doing problems on Earth. But if it tells you to do a problem on a different planet, then you have to remember that that's also going to be negative because gravity is always acts down. Another thing that you need to remember about the acceleration is that you always want to label your graph of acceleration. You always want to label your acceleration on your graph. So if you have something like I just drew, just this. You're drawing your situation. I'm sitting at the top of a cliff. I throw a rock down, and then you label your axis. Okay, I decide that my x direction is going to be this way, and my y direction is going to be this way. Then you just remember that, okay, I know that gravity is acting downwards on this rock. So it's going to be just a double arrow, and then AY is equal to negative 9.8. And if you guys remember, usually the acceleration in the x direction is going to be 0, so the velocity in the x direction is not affected by anything. So it's going to be just ax is equal to 0. So this just helps you keep track of everything that's going on in the problem, because these projectile motion problems usually have a lot of things going on. So it just helps to label and just translate it into something that is easier to solve. So when you're asked questions about projectile motion problems, they're usually going to be asking about how high an object goes, like its maximum height, the distance that's going to travel. So if I throw a rock off the top of a hill, where is it going to land? How far away from me is it going to land? Its velocity, how fast it's going, as well as what direction it is. So it might ask you for the magnitude of the vector, and it might also ask you what the velocity in the x direction is or what the velocity in the y direction is. So handling the velocity in the two different directions, if you remember from vectors, you're just going to use that you're either going to use tangent inverse of b over a to find what the angle is. What the angle that the vector is to the horizontal, or you're also going to be using that Pythagorean theorem. So just like square root of a squared plus b squared is going to be equal to the magnitude of your vector. So a vector v, magnitude would be equal to a squared plus b squared, the square root of that. So they may also ask you for the angle to the horizontal, as I was saying right here. So just that theta right there. And usually these problems just ask for a mix of things. They're gonna give you a certain amount of information. They may give you how far an object goes, how high it is, what its initial velocity was, in one direction or both directions. It can give you any of this information, and your job is basically going to be to use that information to find the rest of the information that they're going to ask you for. So they're more like puzzles. Basically. A lot of them are multi-step. You may have to use different cake equations, but you always want to go for that second cake equation before you go on to anything else, just to keep track of everything. And that's going to be the end of the video. So I'm going to be making more videos in this category. There's going to be a projectile motion part 2 and also a part 3, where I'm just going to be solving some problems symbolically, just to let you guys see how you kind of puzzle through these problems. So if you have any questions about just the basic variables, anything that I went over in this video, please comment, like, and subscribe to our the video, subscribe to our channel, and as always, thanks for watching. Remember, if you have any questions, send it to archismgroup@gmail.com. Thank you for watching, and I'll see you next time.